Welcome to Ancient Relics Keeper, where lost truths, ancient mysteries, and forbidden history collide. Let's question the past and uncover what was never meant to be found. In 2017, a jawbone from a Spanish cave was dated to 400,000 years old. Its features were not Neanderthal but those of an early modern human. This single fossil places our direct ancestors in Europe far earlier than ever believed, in a time dominated by another species. In the heart of Portugal, within the complex network of passages that form the Almanda karst system, a discovery was made that would quietly but fundamentally challenge the established timeline of human history in Europe. The site, known as Cueva de Aroeira, had long been a point of interest for paleoanthropologists. For years, it had yielded tantalizing clues about the deep past ancient stone tools and the fossilized remains of animals that roamed the Iberian Peninsula hundreds of thousands of years ago. But in 2014, during a meticulous excavation, researchers uncovered something far more significant. It was not another tool or the bone of a prehistoric horse. It was a partial human cranium, a direct link to the people who had inhabited this cave in a time so distant it bordered on the unimaginable. This artifact, catalogued as Aroeira 3, was more than just another old bone. It was a piece of a puzzle that science didn't even know was missing. Its existence suggested a narrative of our own origins that was far more complex and intertwined than the accepted models had ever allowed. The process of excavating Aroeira 3 was a testament to the painstaking nature of modern archaeology. The cranium was not found lying loose on the cave floor. It was firmly cemented within a thick, hardened layer of calcite, or stalagmite flowstone, alongside an assortment of stone tools. This geological embrace was both a challenge and a blessing. Extracting the fossil required immense care and precision. Field workers had to use small hammers and chisels to carefully break away the surrounding rock, a process that took 2 years to complete without causing irreparable damage to the priceless specimen within. The cranium itself was incomplete, consisting of the right side of the facial skeleton and a portion of the brain case, but it was enough. It was a tangible remnant of an individual who had lived and died in this very spot. What made the find immediately compelling was not just the human bone itself, but its direct association with the artifacts around it. The stone tools found in the same layer were unmistakably Acheulean. This specific toolmaking tradition, characterized by large teardrop-shaped hand axes and cleavers, is a hallmark of early hominins across Africa, Asia, and Europe. Acheulean tools represent a significant cognitive leap from the simpler Oldowan choppers that preceded them. Their creation requires foresight, planning, and a sophisticated understanding of how to shape stone. The presence of these tools confirmed that the individual from Aroeira was part of a technologically advanced culture for their time. Furthermore, the site was rich with faunal remains, the bones of deer, horses, and even rhinoceroses. Some of these bones bore cut marks, the telltale signs of butchery, indicating that the inhabitants of Cueva de Aroeira were successful hunters, capable of processing large game. This context provided a vivid snapshot of life in the Middle Pleistocene, a world where early humans used sophisticated tools to hunt formidable animals, using caves like Aroeira as a home base or a butchering site. The Aroeira 3 cranium was not an isolated object. It was the central piece of a diorama of ancient life, found exactly where its owner had left it 400 millennia ago. Once the fossil was safely extracted and transported to the laboratory, the next critical step was to determine its precise age. For fossils of this antiquity, the familiar method of carbon-14 dating is completely ineffective, as its range only extends back about 50,000 years. Instead, scientists turned to the geological context of the find. The fact that the cranium had been encased in stalagmite was the key. This type of rock formation provides a near-perfect clock for geologists, through a method known as uranium-thorium dating. The principle behind it is straightforward yet elegant. When water seeps through limestone, it dissolves small amounts of uranium. As this water drips and evaporates inside a cave, it deposits layers of calcite, forming stalagmites. This process traps the uranium atoms within the newly formed rock. From the moment it is locked in place, the uranium begins to decay into another element, thorium, at a very slow and precisely known rate. By measuring the ratio of uranium to thorium in a sample, scientists can calculate with remarkable accuracy how much time has passed since that layer of rock was formed. The team working on Arrow 3 applied this technique to the calcite that had directly surrounded the cranium. They were in an ideal situation, as they could test the layers of flowstone that had formed just before the skull was deposited, and the layers that had formed directly on top of it, sealing it in place. This allowed them to bracket the age of the fossil, creating a minimum and maximum time frame for its deposition. The results were both definitive and startling. The analysis concluded that the Arrow 3 cranium was approximately 400,000 years old. This date was not a rough estimate. It was a scientifically robust conclusion based on the immutable laws of radioactive decay. The number itself, 400,000 years, was profound. It placed the fossil squarely in the Middle Pleistocene epoch, a vast and dynamic period of Earth's history characterized by dramatic climate shifts and the evolution of several hominin species. The significance of this age cannot be overstated. For decades, the prevailing scientific consensus held that Europe during this period was the exclusive domain of the Neanderthals and their direct ancestors, a group often referred to as Homo heidelbergensis. The story was one of a single dominant lineage evolving in relative isolation on the European continent, adapting to the harsh Ice Age environments. Modern humans, Homo sapiens, were thought to be a much more recent addition to the European landscape. The standard out-of-Africa model, supported by a wealth of fossil and genetic evidence, posited that our species evolved in Africa and only began to migrate into Europe around 45,000 to 50,000 years ago. This meant there was supposed to be a gap of over 350,000 years between the time the Arrow individual lived and the arrival of the first modern humans. The 400,000-year-old date from the Portuguese cave did not just push back a deadline. It fundamentally contradicted the established narrative. It placed a hominin with intriguing anatomical features in Western Europe at a time when they simply were not supposed to be there, forcing a re-evaluation of the entire timeline of human presence on the continent. With the context established and the age confirmed, the final and most crucial analysis focused on the anatomy of the Arrow 3 cranium itself. When examining a 400,000-year-old hominin fossil from Europe, paleoanthropologists have a clear set of expectations. They anticipate seeing the classic features of the Neanderthal lineage: a prominent double-arched brow ridge, a long and low skull shape, a large nasal cavity, and a projecting midface. These are the defining characteristics of the hominins that dominated Europe for hundreds of thousands of years. The Arrow 3 cranium, however, did not fully conform to this template. It presented a confusing, mosaic-like combination of traits that defied easy categorization. This anatomical ambiguity was where the true mystery began. On one hand, the fossil clearly possessed some features that aligned it with the Neanderthal family. Most notably, it had a continuous and robust brow ridge, a feature very typical of European hominins from this period, including the Neanderthals and their likely ancestors, Homo heidelbergensis. The bone of the skull was also thick, another primitive trait. These characteristics confirmed that Arrow 3 was not some misplaced, fully modern human. It was deeply rooted in the evolutionary story of Middle Pleistocene Europe. It belonged to its time and place, sharing a clear ancestral connection with the other known hominins of the region. Had the analysis stopped there, the fossil might have been classified as an early Neanderthal or a regional variant of heidelbergensis, and the story would have been far simpler. But the cranium also displayed a suite of features that were conspicuously different from the classic Neanderthal pattern, and, intriguingly, more reminiscent of the anatomy of modern humans. For instance, the small, broken stubs of the nasal bones suggested a smaller nose than what is typical for a Neanderthal. More significantly, certain aspects of the facial structure, such as the shape of the bone around the eye sockets and the maxillary region, appeared more delicate and flattened, lacking the pronounced puffy appearance of a Neanderthal face. While the cranium was damaged, the remaining structures hinted at a facial architecture that deviated from the expected norm. Furthermore, analysis of the mastoid process, a bony prominence behind the ear, revealed a morphology that fell within the range of early Homo sapiens, but was distinct from that of Neanderthals. It was a subtle but important clue, another piece of evidence that this individual did not fit neatly into the predefined category of a pre-Neanderthal. This combination of archaic and modern-looking traits makes Arrow-Era 3 a classic example of a mosaic fossil. It is not an intermediate form lying perfectly on a straight line between an ancestor and a descendant. Instead, it represents a combination of features that, according to the old models, should not have existed together in the same individual. This anatomical puzzle has profound implications. It suggests that human evolution in Europe was not a simple linear progression culminating in the classic Neanderthals. Instead, the picture that emerges is one of much greater diversity and experimentation. There may have been multiple, distinct hominin populations living in Europe during the Middle Pleistocene, each with its own unique blend of physical traits. Some, like the ancestors of the classic Neanderthals, followed one evolutionary path. The Arrow-Era 3 individual may have belonged to another separate lineage, one that was developing in parallel and happened to share certain characteristics with the lineage that would eventually lead to Homo sapiens in Africa. It was a clue that the human family tree in Europe had more branches than previously thought. The Arrow-Era cranium, with its perplexing anatomy, stood as physical proof that our understanding of our own ancient cousins was incomplete. It was not just a fossil. It was a question cast in bone, challenging the very definition of who lived in ancient Europe and what their relationship was to us. For much of the 20th and early 21st centuries, the story of human origins in Europe was told with a confident, almost cinematic clarity. It was a grand narrative, built upon a century of fossil discoveries and archaeological finds, that provided a coherent and seemingly complete account of our deep past. This established timeline was not just a collection of dates and species names. It was a fundamental framework that shaped our understanding of who we are and where we come from. It presented a linear sequential drama with two main protagonists: the long-reigning, indigenous Neanderthals and the recent, ultimately triumphant arrivals Homo sapiens. The story was compelling in its simplicity, offering a clear beginning, a dramatic climax, and a definitive conclusion. It was a story that, for a long time, appeared to fit the available evidence perfectly, creating a scientific consensus that was taught in universities and presented in museums across the world. This old timeline, however, now stands as a monument to a simpler understanding, a foundational story that new discoveries have begun to dismantle piece by piece. At the heart of this traditional narrative was the unquestioned reign of the Neanderthals. They were cast as the quintessential primordial Europeans, the sole human occupants of the continent for an immense stretch of prehistory. Their story began in the depths of the Middle Pleistocene, emerging from earlier hominin populations like Homo heidelbergensis around 400,000 years ago. For the subsequent 350,000 years, they were the undisputed masters of a vast and often unforgiving territory. The fossil record painted a vivid picture of their success and endurance. From the caves of Gibraltar in the south to the plains of Siberia in the east, and from the valleys of the Levant to the coastlines of Wales, Neanderthal remains and their characteristic stone tools were found in abundance. They were a species forged by the cyclical ice ages of the Pleistocene, and their anatomy was a testament to their remarkable adaptation. They possessed a stocky, muscular build, which conserved heat more efficiently than the leaner bodies of their African counterparts. Their large, wide nasal cavities were thought to have been an adaptation to warm and humidify the cold, dry air of Ice Age Europe. Their bones were thick and robust, indicating a physically demanding lifestyle of close-quarters hunting of large, dangerous game like mammoths, woolly rhinoceroses, and giant cave bears. Their dominance was not merely a matter of physical resilience. It was also cultural and technological. Neanderthals were the creators of the Mysterian tool industry, a sophisticated toolkit that represented a significant advance over earlier technologies. Unlike the more generalized Acheulean hand axes, the Mysterian toolkit was diverse and specialized, featuring carefully crafted flint spear points, scrapers for preparing animal hides, and sharp flakes for butchery. They demonstrated advanced cognitive abilities, including the use of the Levallois technique, a complex method of preparing a stone core to strike off a flake of a predetermined size and shape. This required foresight, abstract thought, and meticulous planning. Evidence from numerous sites suggested they were highly effective hunters, not just scavengers, and that they lived in organized social groups. They controlled fire, used pigments, and there is compelling, though still debated, evidence that they intentionally buried their dead. For hundreds of millennia, the Neanderthals were not just surviving in Europe, they were thriving. They were the established, long-running civilization of the Pleistocene, and in the old timeline, their story unfolded in magnificent isolation, with no other human species to challenge their place on the continent. The second act of this long-accepted drama began much more recently, with the arrival of a new character on the European stage, Homo sapiens. The late arrival theory was a cornerstone of the 20th century model of human origins. Based on the available fossil evidence, the consensus was that modern humans, our direct ancestors, evolved exclusively in Africa. The oldest Homo sapiens fossils, found at sites like Jebel Irhoud in Morocco and Omo Kaibish in Ethiopia, dated back as far as 300,000 years, confirming Africa as our species' cradle. For a vast period of time, while Neanderthals were evolving and flourishing in Europe and Asia, Homo sapiens were doing the same in Africa. The critical element of this theory was the timing of their dispersal. The narrative held that modern humans remained within Africa for the majority of their evolutionary history, only venturing out to colonize the rest of the world in a relatively recent wave of migration. According to this model, the first modern humans did not set foot in Europe until around 45,000 to 50,000 years ago. This date was not arbitrary. It was based on the oldest anatomically modern human fossils found on the continent. Sites like Pestra Cuoas, the cave with bones, in Romania yielded a human mandible dated to approximately 40,000 years old, which long stood as one of the earliest definitive examples of a modern human in Europe. Similarly, discoveries in Kent's Cavern in the United Kingdom and various sites in Italy and France all pointed to a similar time frame. This created a clear and unambiguous timeline. For 90% of the Neanderthals' existence, they had Europe entirely to themselves. The arrival of Homo sapiens was depicted as a late, almost abrupt event, a dramatic intrusion into a world that had known only one type of human for eons. This timeline provided a neat and tidy separation between the two species, both geographically and chronologically. It was a simple two-part story. The age of Neanderthals followed by the age of modern humans. The final chapter of this old narrative detailed the transition between these two ages, and it was largely understood as a story of replacement. With Homo sapiens arriving around 45,000 years ago, and the last evidence of Neanderthals disappearing from the fossil record around 40,000 years ago, the period of overlap between the two species appeared to be remarkably brief, perhaps only 5,000 years across the entire continent, and even shorter in specific regions. This short time frame of coexistence strongly suggested that the arrival of modern humans was directly linked to the demise of the Neanderthals. The prevailing view was that the two species were in direct competition, and the Neanderthals lost. This replacement model became the dominant explanation for the Neanderthals' extinction. Scientists propose numerous hypotheses to explain why Homo sapiens would have had a competitive edge. One theory centered on superior cognitive abilities, suggesting that modern humans possess more advanced language skills, which allowed for better social organization, coordinated hunting strategies, and the transmission of knowledge across generations. Another focused on technology. While Neanderthal tools were effective, the Upper Paleolithic toolkit brought by modern humans was even more diverse and innovative, featuring a wider array of materials like bone, ivory, and antler, and new inventions like the spear thrower atlatl, and possibly the bow and arrow. These technologies may have made hunting more efficient and less dangerous. Other theories pointed to differences in social structure, with Homo sapiens potentially living in larger, more interconnected groups with wider social networks, providing a buffer against local resource shortages or environmental changes. Some researchers even suggested that modern humans brought with them new pathogens from Africa, to which the Neanderthals had no immunity, leading to a demographic collapse. Whatever the specific cause, the outcome in the old story was clear and decisive. The Neanderthals, after successfully weathering hundreds of thousands of years of dramatic climate change and ecological challenges, faded into extinction within a few millennia of our ancestors' arrival. The narrative was one of a superior, more adaptable species displacing a more archaic one. It was a classic evolutionary tale of success and failure, a clear-cut transition that left Homo sapiens as the sole human occupants of Europe. This clean ending provided a satisfying resolution to the prehistoric drama, explaining the world as we see it today. This entire framework, the long reign of Neanderthals, the late arrival of modern humans, and the swift replacement formed a cohesive and powerful story that dominated paleoanthropology for generations. It was a story that made sense of the fossil record as it was known, but it was a story whose very foundations would be shaken by discoveries lying dormant in the caves of the Iberian Peninsula. For much of modern science, the history of humanity in Europe was a story told with remarkable confidence, a linear narrative built on a century of discovery that seemed both complete and compelling. This established timeline provided a clear and easily understood framework for our deep past, defined by two distinct and sequential chapters. The first was the long and isolated reign of the Neanderthals, the original indigenous Europeans. The second was the recent and dramatic arrival of our own species, Homo sapiens, who swept across the continent and brought the age of Neanderthals to a swift close. This narrative, powerful in its simplicity, became the bedrock of paleoanthropology, a foundational story that explained the world as we knew it, based on the evidence available at the time. At the core of this traditional model was the absolute dominance of the Neanderthals. They were portrayed as the sole human occupants of the European continent for an immense stretch of prehistory. Emerging from earlier hominin groups like Homo heidelbergensis around 400,000 years ago, they successfully conquered and adapted to a vast and often challenging environment. The fossil record was unambiguous, showing their presence from the southern tip of the Iberian Peninsula to the cold plains of Siberia. They were a species forged by the cyclical ice ages, and their anatomy was a testament to their incredible resilience. They possessed stocky, powerful builds to conserve heat, large nasal passages to warm the frigid air, and robust skeletons indicative of a physically demanding lifestyle. For over 350,000 years, they were the undisputed masters of their domain. Their success was not merely physical. Neanderthals were technologically and culturally sophisticated. They were the creators of the Mysterian stone tool industry, a versatile toolkit featuring carefully prepared spear points, scrapers, and cutting implements. This technology demonstrated advanced cognitive abilities, including abstract thought and meticulous planning. Archaeological evidence from countless sites showed they were highly effective hunters of large game, controlled fire for warmth and cooking, and lived in organized social units. They were not the brutish, hunched-over cavemen of popular imagination, but an intelligent and enduring species that thrived in Europe for a period of time that dwarfs the entirety of recorded human history. In this old accepted timeline, their long story unfolded in magnificent isolation, with no other human species present to challenge their place on the continent. The second act of this established drama began with what was known as the late arrival theory. This cornerstone of the 20th century model stated that modern humans, Homo sapiens, evolved exclusively in Africa and remained there for the vast majority of their existence. While the Neanderthals were flourishing in Ice Age Europe, our own ancestors were evolving under the African sun. According to this narrative, the great out-of-Africa migration that would lead to the colonization of the globe was a relatively recent event. Specifically, the model posited that the first modern humans did not set foot on the European continent until approximately 45,000 to 50,000 years ago. This date was not speculative. It was anchored in the hard evidence of the fossil record as it was then known. The oldest anatomically modern human remains discovered in Europe, at sites like Pestrasiu Oase in Romania or Kent's Cavern in the United Kingdom, all pointed to this time frame. This created a stark and clear chronological separation. It meant that for over 90% of the Neanderthals' time on Earth, they had Europe entirely to themselves. The arrival of Homo sapiens was framed as a late, almost abrupt event, a dramatic intrusion into a world that had known only one type of human for hundreds of thousands of years. This timeline was neat and tidy, creating a clear geographical and chronological divide between the two species and simplifying the complex tapestry of human evolution into a two-part story. First came the age of the Neanderthals, and then much later came the age of us. The final chapter of this long-held narrative described the transition between these two ages, and it was overwhelmingly seen as a story of replacement. With Homo sapiens arriving around 45,000 years ago, and the last conclusive evidence of Neanderthals vanishing around 40,000 years ago, the period of direct overlap seemed remarkably brief. This short window of coexistence, perhaps only a few thousand years across the entire continent, strongly implied a direct cause and effect relationship. The arrival of modern humans was seen as the trigger for the Neanderthals' demise. This replacement model became the dominant explanation for their extinction. Scientists proposed numerous reasons for the perceived superiority of the newcomers. Perhaps Homo sapiens possessed more advanced cognitive abilities, including complex language that allowed for better social organization and planning. Perhaps their Upper Paleolithic toolkit, which included innovative new weapons like the spear thrower, gave them a decisive advantage in hunting. Other theories suggested that modern humans had more extensive social networks, allowing them to share information and resources over wider areas, providing a crucial buffer against environmental change. The narrative was one of competition for limited resources, a competition that the Neanderthals, for all their past success, ultimately lost. After weathering countless ice ages, they faded away within a few millennia of our ancestors' arrival. The story was clear. One species replaced another. This cohesive and powerful framework of Neanderthal dominance, a late human arrival, and a swift replacement offered a complete and satisfying explanation for the fossil record. It was a story that made perfect sense, until a single jawbone from a Spanish cave began to suggest that the story was not over, and perhaps had never been that simple at all. The find blurs the line that once clearly separated the two species. While genetics confirmed they created a shared lineage, the full story of their ancient relationship in Europe remains buried, waiting for the next piece of evidence to be unearthed. Thanks for exploring with Ancient Relics Keeper. Stay curious, question everything, and remember the truth is often buried deeper than we think.